Hello students, and you are welcome back to Solve Your Past Question class. We've been solving quite a lot of questions on motion and everything that surrounds it. In our previous classes, we've been solving questions from West African Examination Council, WAEC, from the year 2000-2010 and focusing on motion, types of motion, Newton's laws of motion, and simple harmonic motion. Today, our questions will range from 2005-2010 on the same topics. So get your writing materials and ready to solve, shall we? The first question says that a body is rotating in a horizontal circle of radius 2.5 meter with an angular speed of 5 rads per second. Calculate the magnitude of the radial acceleration of the body. The first thing we have to do is that I want you to know that you will be able to solve these questions if you've gone through our classes on simple harmonic motion. So quickly, let's solve this question. The magnitude of the radial acceleration AR of an object moving in circle is given by the formula AR equals to V squared divided by R, where V is the linear velocity of the object and R is the radius of the circle. All right. Then given that from our question, we have radius to be 2.5 meter, angular speed, which is the sign that looks like W, to be 5 rad per second, then we can say that we can calculate the linear velocity V using the formula V equals to radius times angular velocity. So let's calculate our V. V is 2.5 times 5, which is 12.5 meter per second. Now we can plug in V into the formula for radial acceleration from the first formula we just used, which is AR equals to 12.5 squared divided by 2.5, which is 62.5 meter per second square as the final answer for radial acceleration. So the magnitude of the radial acceleration of the magnitude is 62.5 meter per second square. Good. Let's solve another question. A body of mass 4 kg resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces 6 Newton and 8 Newton. Calculate the acceleration of the motion. To find the acceleration of the motion, we first need to calculate the force acting on the body and then use Newton's second law, which states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Given that the body is on a smooth horizontal plane, there is no friction, so the only forces acting on it are the two perpendicular forces, which is F1 to be 6 Newton, F2 to be 8 Newton. The net force, which is F net, can be found using Pythagoras theorem, since the forces are perpendicular to each other. So we have the F net, which is the total force, which is equals to all square root of F1 plus F2 squared, or F1 squared plus F2 squared. Then total net force equals to all square root of 6 Newton squared plus 8 Newton squared. Then we have all square root of 36 plus 64 Newton. Then we have a total of all square root of 100 Newton when we add them together. Then the square root of 100 is 10 Newton. So our net force is 10 Newton. Now we can use the Newton's second law of motions, which is F net is now equals to m times acceleration, or mass times acceleration, where m is the mass, which is the body, which is 4 kg, and a is the acceleration. Plugging in our values, we have our net force to be 10 Newton equals to 4 kg times acceleration. Then making a the subject of formula, or which is acceleration the subject of formula, we have 10 Newton divided by 4 kg, which is 2.5 meter per second square, which is our final answer for our acceleration. So the acceleration of the motion is 2.5 meter per second square. This is where I want us to stop for today's class, and we'll continue shortly in the next, where we're going to be solving questions from our past questions relating to other various topics that we're about to touch. Thank you for joining us for today's class. See you soon.